Welcome to this explainer. Today, we're building your ultimate exam cheat sheet, transforming dense math formulas into the exact, practical tools you need to solve rigorous problems fast. If you've ever stared at a test paper and felt like the numbers were written in some alien language, you are absolutely in the right place. We're focusing purely on the most high-yield concepts, using simple analogies and targeted practice problems to get you fully prepped and feeling confident. We have a packed agenda today. We're going to cover 1. The Algebra Foundation, 2. Measuring the math universe, 3. Unlocking trigonometric ratios, 4. The Pythagorean Identities, 5. Advanced angle formulas, and finally, 6. Exam practice and mastery. Let's get right into it. Starting off with Section 1, the Algebra Foundation. To start, we really have to understand the core building blocks of our equations, because algebra is literally the engine that drives everything else we're doing today. When you're finding the roots of a quadratic equation, think of it like extracting the very DNA of the formula. You're hunting for those exact x values that balance everything perfectly to 0. Now, when you're sitting in an exam, you generally have two solid pathways to extract this DNA. You can either use the intuitive method of splitting the middle term, or, if the numbers are being stubborn, you can break out the heavy artillery, the classic Sridharacharya formula, also known as the quadratic formula. This is such a brilliant way to crack an exam problem fast. Take the equation x squared plus 7x plus 12 equals 0. You just got to ask yourself, what two numbers multiply to 12 and also add up to 7? Well, 3 and 4. You split that middle term, factor it out, and boom, your roots are -4 and -3. It's like a satisfying little puzzle, and it's incredibly efficient once you know what to look for. Moving right along to Section 2, Measuring the Math Universe. So our algebra is locked in. Let's step into geometry. Before we can calculate anything with triangles, we need to understand the basic units of the universe we're operating in. Instead of memorizing a boring, rigid formula, just think of measuring an angle in radians like measuring a pizza slice. If you want to know the size of the angle at the point of your slice, just take the length of the crust, that's your arc length, S, and divide it by the straight edge of the slice, which is your radius, R. That simple division gives you the angle theta in radians. It totally grounds an abstract concept into something you can easily visualize on test day. For exams, you need to seamlessly jump between these two universes: degrees, which we use in everyday life, and radians, the standard SI unit preferred in advanced math. Definitely lock this simple conversion into your memory. If you're starting with degrees and want radians, you just multiply by pi over 180. Starting with radians and need to get back to degrees, just flip it. Multiply by 180 over pi. To put that into perspective, think about a complete rotation around our pizza. That is 360 degrees, which gives an arc length of the full circumference, or exactly 2 pi radians. If we cut that in half, 180 degrees equals exactly pi radians. From there, everything else just falls right into place. 90 degrees is pi over 2, 60 is pi over 3, and so on. Getting familiar with these standard conversions gives you a massive advantage because it lets you bypass the manual math completely during a timed test. All right, Section 3, Unlocking Trigonometric Ratios. Let's look at how angles actually relate to the physical sides of a triangle, because this is where the real magic of trigonometry happens. These aren't just abstract ideas. They are literally your blueprint ratios. They let you rebuild an entire triangle structure just by knowing a couple of measurements. If you've got a right-angle triangle, your sine is the perpendicular side over the hypotenuse. Cosine is the base over the hypotenuse, and tangent is the perpendicular side over the base. Master these 3 blueprints, and there isn't a right triangle in the world that can keep its dimensions hidden from you. Now, I know staring at a giant table of roots and fractions can be a bit intimidating, but look closely at the hidden pattern here. Notice how the sine values steadily increase as the angle gets larger? They go from 0 to 1/2, all the way up to 1 and 90 degrees. But then look at cosine. It does the exact opposite. It starts at 1 and perfectly mirrors the sine values in reverse, counting down to 0. And tangent? It's just sine divided by cosine. Once you see these connections, rote memorization becomes totally unnecessary. Here is an absolute game changer for exams: standard Pythagorean triplets. We're talking about exact ratio combinations like 3, 4, 5, 6, 8, 10, 7, 24, 25, and 5, 12, 13. If a test tells you the perpendicular side is 3 and the base is 4, do not waste time squaring them, adding them, and taking the square root. You instantly know the hypotenuse is 5. Memorizing these standard triangles is literally like having a VIP fast pass for your exam. Let's level this up in Section 4, the Pythagorean Identities. So what happens when we combine the Pythagorean theorem with those blueprint ratios we just learned? We uncover some unbreakable math rules. Take the standard Pythagorean theorem, base squared plus perpendicular squared equals hypotenuse squared. If you simply divide every single term by the hypotenuse squared, you naturally derive these vital identities. Perpendicular over hypotenuse becomes sine, base over hypotenuse becomes cosine, and hypotenuse over hypotenuse is just 1. That gives us our absolute golden rule. Sine squared theta plus cosine squared theta equals 1. Divide by the base squared or perpendicular squared instead, and you easily unlock the other two. See? You don't have to blindly memorize them, you just need to know how they're built. On to Section 5, Advanced Angle Formulas. Okay, we're ready for the tricky stuff. We've mastered the standard angles, but exams love to push you out of your comfort zone. This is a classic curveball. 75 degrees is nowhere on our neat little blueprint table, but how on earth do we calculate it? Well, there's a straightforward formula to crack it, and it relies entirely on the standard angles we already know and love. Enter the compound angle formulas. By breaking an unfamiliar angle down into a sum or difference of standard angles, let's call them A and B, these formulas let you solve for almost anything. The sine compound formula beautifully alternates sine A cosine B plus cosine A sine B. The cosine formula keeps the like terms together but flips the sign in the middle. These are ridiculously powerful tools to have in your exam toolkit. Let's actually see this in action. Take that mystery angle of 75 and deconstruct it into 30 plus 45. Then, you just plug those numbers straight into the sine compound formula we just talked about. Because 30 and 45 are standard table values, you literally just swap out the trig functions for their actual numbers, like 1/2 and 1 over root 2. Multiply them out and synthesize your final answer. It takes what looks like an impossible problem and turns it into basic arithmetic. Finally, Section 6, Exam Practice and Mastery. Knowing the theory is great, but applying it is what actually gets you the top score. Let's put it all together and run through some high-speed practice problems. Whenever an exam gives you one ratio, like tangent theta equals 2, do not panic. Just remember that 2 is exactly the same as 2 over 1. Since tangent is perpendicular over base, just visualize an imaginary right triangle. Your perpendicular side is 2, your base is 1. Find that missing third side, the hypotenuse, using Pythagoras, which gives us the square root of 5. Now that you have all three sides, you can instantly define any other ratio. Sine becomes 2 over root 5. Cosine becomes 1 over root 5. Super simple, right? And here is where memorizing those standard triplets pays off big time. Say sine is 3 over 5. That means perpendicular is 3, hypotenuse is 5. Instead of doing the Pythagorean theorem and wasting a precious minute of your exam, seeing a 3 and a 5 on those specific sides instantly tells you the base is 4. You skip the math entirely. From there, tangent is 3 over 4, and cosine is 4 over 5. You can solve a problem like this in less than 10 seconds. What if your exam asks for double an angle, like finding the sine of 74 degrees when you only know 37? You don't even need the full compound formula. Just use these massive time-saving shortcuts. Sine 2 theta is simply 2 times sine theta times cosine theta. These derivations pop up all the time in higher-level physics and math problems, so keeping them in your back pocket will give you a tremendous edge. Also, always remember that sine and cosine are perfect mirrors for complementary angles. If two angles add up to 90 degrees, they're complementary. That means the sine of one angle is absolutely identical to the cosine of its 90-degree complement. So if you've already done the hard work of figuring out that the sine of 15 degrees is root 3 minus 1 over 2 root 2, well, you automatically know the cosine of 75 degrees. It's the exact same number. Always let the math do the heavy lifting for you. So you now have the complete mathematical toolkit. We've built the foundation, cracked the triangles, and mastered the shortcuts. But I want to leave you with a challenge. Apply these building blocks to the full coordinate plane. If you visualize a circle on an XY graph where the radius is the hypotenuse, what actually happens to your base and perpendicular sides when you stretch that angle all the way flat to 180 degrees? See if you can use everything we just covered to prove exactly why sine 180 is 0 and cosine 180 is -1. See if you can unlock the rest of the unit circle for yourself. Keep practicing those triplets, stay confident, and I'll catch you in the next explainer.